Good morning, my YouTube viewers. Crystal here. What I wanted to do this morning was I wanted to give you the solution to the analytics VidHaya predict the number of upvotes competition question, and I used MLPR. That was a type of deep learning, I believe. It's sort of like how TensorFlow uses Keras, because Keras is deep learning, but this is a deep learning in sklearn. And what I did was, whenever I did this problem, I originally did it a few months ago, I think in August, and I had used the code that I got off the internet, and it was very elaborate, complex code. And whenever I plugged that code in, I came up with a value of 860, because don't calculate on accuracy. They calculate on something called root mean squared error. Not root mean squared error, another one you'll find out. And basically, I decided to come back and go back and take this problem and do it myself, because I thought, well, it's not good you copy somebody else's code, because you're not really learning very much if you're copying somebody else's code. So you're going to have to do this yourself. So that's basically what I did. I did it myself. And basically, when I did it, I got a reading in the 3000s. And I know it sounds really awful. You're like, oh my God, how could you get a reading in the 3000s? But some people got readings a lot higher than that. And the lowest reading was about 160. And I tried everything that I could think of to get the reading down. I looked at my code and I compared it to this lady's code, and I did pretty much the same thing that she did, but maybe in a different fashion. But I completed all the steps that she completed, but maybe I didn't do it exactly the way that she did it. But so, I have to do my own work, because if I'm not doing my own work, one, I'm plagiarizing, and two, I'm not really learning how to do data science if I'm not doing my own work. So I decided that even though I got a reading in the 3000s, it's not as bad as some readings that I saw, because I went to the leaderboard, and some readings are in the millions or the billions or the trillions. So 3000 isn't too bad when you look at it that way. So the first thing I'm going to do is I'm going to read you the proper problem statement for the analytics VidHaya predict the number of upvotes competition question. The problem statement is: an online question and answer platform has hired you as a data scientist to identify the question authors on the platform. This identification will bring more insight into increasing user engagement. Given the tag of the question, number of views received, number of answers, username, and reputation of the question author, the problem requires you to predict the upvote count that the question will receive. So the first thing I did was and you can see that I imported the standard libraries. The second thing I did was I loaded the files, and the files were loaded into my drive on my Chromebook. And the reason why is because the files were so large, I could not put them in a repository in GitHub, because basically what I do is I only open a GitHub repository if I can put the files in there, because that's really the nature of why I'm opening a repository, so I don't have to save the files on my computer and use up my computer's memory. So after I've loaded the files, I looked at the train file, and you can see the train file has ID tag, reputation, answers, username, views, and upvotes. Looked at the test file. The test file has the same thing except for upvotes. looked at the sample sub. What analytics VidHi I wanted to see was the ID and the upvote. I checked for any null values. Fortunately, there were no null values, so I didn't have to fill in the missing values. I pre-processed and graphically represented the data. So I did a group by on tags so you can see which tags, how many of each thing was allocated to each tag. The next thing I did was I did a heat map so you can see how the upvotes relates to every other independent variable. We did a distribution chart so you can see how the answers relate to the tags. And we also wanted to see how the views relate to the tags as well. The next thing we did was we did a group by on tags and upvotes so you can see how many upvotes each tag got, each tag received. So, and then we did a graph on that so you can see a graphical representation of how many upvotes each tag received. Now we did put it in a label encoder, and so every tag was allocated a number instead of a letter. And then we made the reputation column an integer. And then we did another label encoder just to see again how the reputation of the person, and you can see there were 16,527 possible variables. So, and the thing is, it's like when you have a lot of choice, then it's going to make it more difficult for the computer to make a decision because it's got so many choices it has to go through. So we did the reputation frequency, and we wanted to see an allocation of the reputation. And so it was like closer to 0 where you had the most traffic. So the next thing we did was we made the answers an integer. And then you can see the answers again after we made it an integer, and you only had like 63 variables as opposed to the 1,000 previously, because you need to get the variables down, because when you get the more variables you have, the more room for error you're going to have. It's going to be more difficult for the computer to train the file, train the data. And so we did another violin chart on the answers, and you can see this chart was a little bit different, but it's like close to less than 10 is where you have most of the traffic. So then what we did was we checked the user. Again, with the user, you had 141,802 users. So that's a lot of data for the computer program to go through. We did a violin chart on that, and you can see that it's pretty much an even distribution of usernames. We made the username an integer. And the next thing we wanted to do was we wanted to test the views, do a group by on the views, and then you can see there's a lot of variation in the views as well. So we did that on a violin chart, and again, it's the main views are closer to 0. So probably what I'm going to do is I'm probably going to, well, that's an integer as well. So, and then what we did was we created a column called watched. And if in this watched value was dependent on whether people were going to watch it based upon the views. That was for the train file, and now we're doing it for the test file, exactly the same thing. So basically, people watch the answer in relation to the views. And then what we did was we defined our x, y, and x test variable. So we selected our features. And then after we selected our features, we said y is train upvotes, x is train features, and x test is test features. Then we split our test data set for training purposes. X train, X val, Y train, Y val equals train test split. X, Y, train size equals 0.1, random state is 205. Then we put it on the standard scaler to make all the variables within the same range, so it will be easier for the computer to train the data. And then we wanted to see the shape of X train, X val, Y train, and Y val. And so you can see X val because I wanted to see what X val looked like, because when I was going through the program, troubleshooting the program, there was an issue with X val, and you'll notice there's lots of negative values in there. So what we used was, I kept this in here, I kept gradient boosting in here, but gradient boosting is actually slightly less efficient than MLP regressor, but I kept the code for gradient boosting in there anyway, because it was still a good model to use, although it wasn't as good as MLP regressor. So we use model equals MLP regressor, random state equals 1, max iterations is 500, early stopping is true, fit X train, Y train, and you have to set up early stopping, because if you don't set up early stopping, the program will just go along forever, because it just sits there churning while it's looking for the best answer. And if you set up early stopping, as soon as it's no longer improving, then it'll stop. Model equals predict X val, so we're predicting on the valuation part of the train set, or the test part of the train set. And then we checked our score. Our score was 35%, which is pretty low, but when I was using linear regression, the score was like 17%. When I was using another model, the score was like 30%. So 35% was as high as I could get. I tried my best to get it higher, and this one lady that used the program that I worked on, she did pretty much the same thing that I did, and she got a higher score. And that's just the way it works. It's like the different procedures and paths and processes increase noise into the system, and when you increase noise into the system, you have a higher expectation of error. And I will say that what she did was a lot more elaborate than what I did, because I just tried to keep it really simple, and I just still had lots of noise in the 3000s, and she only had noise in the 800s. And I did basically the same thing that she did, but just like in a different fashion. So we checked our mean. So our mean was 4416857. So now we predict on our X val again, just for a yprad equals model.predict X val. And you can see we have an array of digits there. Our accuracy is 35.35, which is not very good, but it's better than what I previously had. And we make predictions on the X val, so you can see the Y val and what the X val predicted. I don't think it's very good. And then what we do is we predict on the X test, and you can see we have the array of variables in the X test. And then we send the output to a data frame. And then when we send our output to the data frame, then what you can do is you come over here on your Google Colab, and it's not connected, and I'm not going to connect it. But if you had connected it, then what you would see, if it had been connected, because it's a big palava just to get it connected, and you can see it's mounting the Google Drive now because of what I did. You'll see the mysubmission.csv. You can take mysubmission.csv and you can download it, and then it'll go into your download file. And then when it goes into your download file, you can upload it into the Analytics VidHaya Solution Checker website, which I know you can't see because of the way my screen recorder works. My screen recorder only allows me to focus on one tab, and I just like that screen recorder. I'm going to use it for the time being. I think it probably doesn't use as much memory either, since it only views one tab instead of the whole desktop. And then so then you put it on then you put it on Solution Checker. After you've got your solution, you can check your submissions, and that's how I found out that my reading was like in the early 3000s, which I know it's not great, but it's better than some people. Some people had in the millions, the billions, and the trillions. So, and I don't think it had a very good output. This one lady that did it, her noise or root mean square error was in the 800s, which, again, as I said, I did the same thing she did, just maybe not in the same sequence of tasks, but I did basically the same thing she did, and she had a lot less noise than me, except for she used the polynomial formula, and I went and studied polynomials and tried to use a polynomial formula, and my accuracy didn't increase. I found out I got the best result on the MLPR, so I stuck with that. And the highest one was 160. And in order to get a really low error rate, you have to do lots of fancy programming in order to get that. And unfortunately, I don't know enough to do that fancy programming at this point in time, but maybe at some point I will. We'll just keep working on it and see what happens. So that concludes this presentation on the solution to the Analytics VidHaya predictive number of upvotes question. If you like my video, please like, subscribe, and share. If you like the work I do, then please, I've got my email address for a PayPal donation if you want to donate into my PayPal account. I don't have enough subscribers, so the only way I can make money on this channel is to ask for donations. And thank you so much for watching my video, and I look forward to making the next one for you.